Welcome to Methamphetamine. Today we are going to do two sessions video, and we are going to do a first session first. So we're gonna evaluate the integral of ln of 1 plus psi square x from 0 to the power of 2. So let me just write down the original question. Integral of ln of 1 plus psi square x dx going from 0 to the power of 2 like that. So here's the deal. If this is a negative sign, it will be much easier. But how can we integrate this stuff? So here's the deal. This kind of hard to integrate. Just ln of 1 plus something, psi square of something. We are going to use the Feynman technique this here. So we are going to let our I of A is equal to. Where should we put the A inside? So I would like to put the A here. You can put the A in here. I think that integral will converge as well. So you can give it a try. And you can also put the A in front of the psi squares. Up to you. But I would just put the A here. A plus psi squares. Like that. ln of A plus psi squares. Yes. So here's the deal. After we integrate differentiate both sides, right? We're gonna differentiate both sides with respect to A, and then we're gonna integrate on one side once again. After you integrate, you're going to get a constant. So the constant, be sure we need to choose a random number to figure out if this converges as well. So A cannot be negative. So if A is we always consider A is greater or equal to 0, or A is just greater than 0, because I don't like negative. I always want A is a positive. It's greater than 0 or greater or equal to 0. So, and not the negative value. So, here, put 0 into it. 0, you pretty much just integrate ln of psi squares from 0 to the power of 2. Because of a lab property, you can put a 2 outside the integral, right? ln of psi squares. Put a 2 outside. And the integral of ln of psi x going from 0 to the power of 2. And you will get a really famous result. So, this integral will be convergence. So, we consider A can be greater or equal to 0. Or equal to 0. So, we can differentiate both sides. I've mentioned we can put A. I think we can put A here because ln of 1 plus psi square of AX. Because psi something, you always gonna get negative 1 to 1, right? So your maximum value will be 1 here, consider. So if A is extremely big number, your maximum values, you're still gonna get 1. So ln of 1 plus something that's closer to 1. You pretty much just converges the integral. You should take a try. I think you can try to put the A here. So we can differentiate both sides now. I prime of A is equal to that. So differentiate ln, first you get 1 over that, 1 over the inside. And the second thing we're going to do, differentiate inside, with respect to A. So differentiate A in our A row, you get 1. And then differentiate psi square x. Psi square x in our A row, you pretty much just get a constant. So you pretty much just get integral of 1 over A plus psi square x, going from 0 to the power of 2. So here's the deal. How can we deal with this integral though? How to integrate 1 over A plus psi square x. And here's the deal. Whenever you see a psi square x in the denominator, we can divide by cosine square x on both the numerator and denominator. So 1 divided by cosine square x, you pretty much just get secant square x, right? So A over cosine square x is equal to A times secant square x. And the sine square x over cosine square x, you pretty much just get tangent square x. This. So mindful. So why do we do this? Because after we divide by cosine square x, you will get secant square, and the tangent. This is really good for us because we can use our substitution. Let u is equal to tangent x. Du will be equal to secant square x dx. So this will become our du. So for it become 1 times du, right? And then 1 over a times our secant. And the secant square x, change it into our tangent into our u. And the secant square x is equal to 1 plus tangent square x. So far you will get 1 plus u squared, right? Because tangent is just our u, and then square that. And then plus u squared, right? Tangent is our u. And then we are going to figure out what's our lower limit and upper limit. Plus 0 into it. Tangent 0, you will get 0. And then tangent of pi over 2, you get infinity. So here's the deal. How can we integrate 1 over a times 1 plus u squared plus u squared? We are going to multi-distribute the a. Distribute the a, you will get a. You pretty much just get a plus a u squared plus u squared. And then that a u squared plus u squared you can combine into our a plus 1 u squared du. And we are going to use the this formula, the inverse tangent formula. That said, the integral of 1 over a plus x, a squared plus x squared dx is equal to 1 over a times inverse tangent of x over a plus c, like that. So we want a square here. So let me just write as square root of a and then square that. You will get the original back. And this, I would like to get a square, right? So we can write this as square root of a plus 1 times u. And then put the square outside. You get the original back, right? So we can apply this formula right now. So you pretty much just get 1 over this square root of a. 1 over square root of a. Here's the deal. Because you can use our substitution, let w is equal to inside. So let me just write is use this formula first. So 1 over square root of a times inverse tangent of the x is just this. Square root of a plus 1 times u divided by our a, which is square root of a. You can use a substitution, you are going to multiply by our 1 over square root of a plus 1 in front to cancel the derivative, right? Just the inverse. The integral, you just do the inverse of the derivative, inverse of the chain rule. So you're going to multiply by 1 over square root of a plus 1. Of course, you can use our substitution. Up to you. Let w is equal to the inside. So we are going to evaluating from 0 to infinity. So whatever inside is inverse tangent, and then put infinity, you pretty much just get inverse tangent of infinity. You pretty much just get pi over 2, right? Pi over 2 times square root of a. Write down the square root of a in front. And square root of a plus 1. Pi over 2 times square root of a times square root of a plus 1. And then inverse tangent of 0, you just get 0. So minus 0 is just that. So we can integrate both sides now. This integral can actually be integrated. 1 over square root of a times square root of a plus 1. Let me do it right here. Integrate both sides. So this pi over 2 is a constant. Let me just put it outside the integral. Integrate 1 over square root of a times square root of a plus 1 dA. because we are integrate this function in our able, so we are going to use dA. So we already use u, so let me just use w this time. Let w is equal to a random. I think let square root of a will be better, and then we are going to square both sides. W square is equal to a, and then differentiate both sides. You will get 2w dw is equal to, sorry, wait a minute. I think you cannot see. You can see it clear now. 2w dw will be equal to our dA. So far, in front you have pi over 2. Our dA will be equal to 2w. Put a constant 2 in front of the integral. And then w on the top. The square root of a is just w. And then what's our square root of a plus 1? You can add both sides. A plus 1 will be equal to, let me just put down w square. Why do I do this? Put a w square inside. You pretty much just get square root of w square plus 1 dw. You see, this w and this w will cancel each other out, and then this 2 and this 2, they cancel each other out. So we are going to integrate 1 over square root of w square plus 1. So integrate this, you get inverse hyperbolic sine, which is inverse sinh. You should memorize this. The integral, because the derivative of inverse sinh is just equal to 1 over square root of w square plus 1. Inverse sinh of w. So you pretty much just get inverse sinh of our, and there w is just equal to square root of a. Put down a square root of a here. Plus c. So we are going to put down the result here. Because this is a indefinite integral, we are going to put down a plus c. Pi times inverse sinh of square root of a plus c. And then we are going to figure out what the c is. So we already know I of a is equal to this, which is also equal to this. So let this is equal to that. Ln of a plus this integral, right? So remember, as I mentioned before, a can be 0. That integral will be convergence. So choose a is equal to 0. So inverse sinh of 0, square root of 0 is 0. Inverse sinh of 0, you get 0. So far you get 0 times pi is 0. But the c is equal to the integral of this 0. Just 0 plus that over, you get ln of sine square x dx. So because of the log property, and because the integral is going from 0 to pi over 2, sine x is always gonna be positive or negative or 0. So forget about the absolute value. So you pretty much just get 2 times the integral of ln of sine x dx, going from 0 to pi over 2. And you will get a famous result. The integral of this, you will get negative pi over 2 ln 2. So you will get 2 and 2, they cancel each other out. You will get negative pi ln 2. So for our I of a will be equal to pi times inverse sinh of square root of a minus pi ln 2. This is really, really cool, you know. We can also combine them. Why not? We can combine them, the pi, you will get a really cool result. Parentheses, inverse sinh of square root of a minus ln 2 times pi. This is really, really cool. And then our original integral compared to each other, you will get a is equal to 1. So let me just write down the result here. This integral, you pretty much just put down a 1 inside. You get inverse sinh of square root of 1 is just 1 minus ln 2 times pi. And inverse sinh of 1 is just inverse sinh of 1. and it cannot be simplified anymore. So here's your result of this. This is a really cool answer. And if you put down the result on Wolfram Alpha, so let me just put down the result of this. Integral of our ln of 1 plus psi square x from 0 to pi over 2. You get 0.591, and it cannot, and Wolfram Alpha cannot give you a exact the exact result, exact value. So let me just figure out the value of this. So you pretty much just get, how can we type the inverse singe on our calculator? First, you're going to do a strip. That's this, because of course every calculator is not the same. So here's the deal: inverse singe, inverse shift, and then click on HYP, and then take a psi, get a psi. Singe of 1 minus ln 2. And then multiply by pi, right? You get, you get 0.591, which is the result that Wolfram Alpha give you. So this is about 0.591. So we can do something that Wolfram Alpha cannot do. This is really, really cool. I'm afraid you did this. This is really, really cool, you know. So let me just keep continue. So we are going to do a session 2. Find the volume of y is equal to square root of the absolute value. This is absolute value. I should write it longer. So find the volume of y is equal to square root of absolute value of ln parentheses of 1 minus psi power of 4x. This is a really complicated function, but don't worry. Then rotate about the x-axis from 0, x is equal to 0 to x is equal to pi over 2. So the volume you pretty much just get, because this x-axis rotate about the x-axis, so this is just a dx. So be sure you should remember the formula. That is the volume rotates about the x-axis. You will get, let me use the v as a volume. V is equal to our pi times our integral from 0 to pi over 2, you know. And then time our y. This is our y. We should square that, and then absolute value of ln of parentheses of 1 minus psi power 4 x dx. Sorry, I may pronounce this kind of wrong. So square that. You may ask me why I put down the absolute value. Because psi of something is always gonna get negative 1 to 1, right? And then power of 4, your maximum value. Let me consider the maximum value. You get 1, right? It's about 1, and then 1 power of 4, you get 1. Let me choose a number that's closer to 1, but not greater than 1. Closer than 1. Let me choose 0.999. Psi of 0.999 will give you about 0.1, and then power of 4, and then 1 minus that. And then the inside is always gonna get about 0 to our x to 1, right? From 0 to 1, the value. So you get a negative result, and then take a square. If we do not put down an absolute value, take a square root of that. You pretty much just get a. If you put down the graph of this, it cannot show you the graph of it because the domain is just. I think this function does not exist if we do not put down an absolute value. So far, let's just continue. So this square root of that square, they pretty much just cancel each other out. So you're going to integral of L1 of 1 minus sine power 4x dx. Be sure you should get an absolute value. So remember, here's a property. The integral of if we just have a absolute value here, we can just put down an absolute value outside integral. Here's the property. My phone ring. So you can put the absolute value outside the integral. Here's the property, From 0 to power of 2 times ln of 1 minus sine power 4x dx. Dx. We should put down a dx here. So we already do the integral of ln of 1 plus sine squared x. So 1 minus sine power 4x, we can do more work. So you pretty much just get pi times that. Here you can write this as 1 minus sine square x and then square. So we can write this as ln of 1 minus sine square x times 1 plus sine square x. Right? We should put the parentheses, I think. Dx. And then use the Pareto law of the ln. You can get pi times the absolute value of this. ln of 1 minus sine square x dx. And then plus another integral ln of 1 plus sine square x dx. So let me just do the integral here. It will take us much less time. So here's the deal. We're going to evaluate ln of 1 minus sine square x dx from 0 to power of 2. And then 1 minus sine square x, you get ln of cosine square x, right? And then you can put up 2 outside the integral. You get 2 times the integral of ln of cosine x dx. Because cosine x is always going to be positive from 0 to power of 2. So just another absolute value. And then this is also a famous result. This is just 2 times negative pi over, this is just negative pi over 2 times ln 2. So simplify to negative pi ln 2, which is the thing we are already doing here. But this integral is exactly the same as this. You can put pi over 2 minus x inside the list of the property. Integral of f of x going from 0 to a. You can use that property by itself. So you get pi times absolute value of negative pi ln 2. And this integral we already do it. It's just this. You pretty much just get plus inverse sinh of 1 minus ln 2 times pi. Put down absolute value instead. So for what is negative pi ln 2? So use the calculator. Negative pi times ln 2. You get negative 2 times 1a. And this absolute value will help us at all. It can help us. Really help us. So you get a number. Let me just put down result. Trying to put down, calculate what's the result. Yep. We cannot distribute the pi inside. We cannot distribute the pi inside, you know. Epsilon value, you cannot, just don't do that. If you are going to get negative pi ln2 plus inverse sinh of 1 minus ln2 times pi. Take an absolute value of this, so you get positive, right? And then multiply by pi. Let me just put down the result. Say it to be our a, and then a times our pi, you get this is about 4.98. And if you put down the result of this, Wolf alpha cannot show you the form of this. We can do this. Pi times this, epsilon of this. So let me try to distribute the pi inside. Let me see what happened. I forget about the property, sorry. So negative pi square times ln2 plus pi square times inverse hyperbolic sine 1 minus ln2. We can distribute it. We can actually distribute it. So I think you can leave this answer. This is okay. Yes, you will get a negative value out inside and then take an epsilon value of this value. Sorry, I mispronounced in my video for many times. So you can distribute it. That's okay. So here's is just our result. We can simplify it more, I think. Negative pi square ln2 plus inverse sinh 1 minus ln2 times pi square. And then you can combine them to our absolute value of this. So pi, it should be inverse sinh of 1 and then minus 2 times ln2 times pi and take an absolute value of this. And this result is really cool. And that's it. This video is already enough. I think we should stop it right now. But wait a minute. Sorry, I forget about the square. What happened to me today? So that's it. This is our result.